Hello and howdy, my fellow mathletes. Root Beer here, looking at question number 24 on the grade 7 Gauss from 2007. In the multiplication shown, P, Q, and R are all different digits, so the different might be something worth noting. And we have PPQ times Q is RQ 5Q. What is the value of P plus Q plus R? Now, I can't see any clever way to manipulate the expression that they've given us and just get P plus Q plus R without just figuring out what is P, what is Q, what is R. So I think that's probably the best way to go about this question. And we'll copy the equation into our diagram. We have PPQ times Q, and then we have RQ 5Q. The R is kind of odd in that it's sort of just left out. The only way to determine R is to figure out P and Q. Now there's a lot of Q's, so you might say, well, let's focus on Q first. Most notably, how do we do multiplication? Especially with a single digit, we take this Q, and we would put Q squared down here, and then there'd be a 0, and then whatever Q times P is, plus any carried digits or anything like that. But the first thing we do is we do Q squared. And so, just looking at the units digits, right, because when we do something like 123 times 4, you do 4 times 3 is 12, and then you put a 0 here, 4 times 2 is 8, and then you do 4 times, you put 2 zeros here, 4 times 1 is 4, and we add them all up. But the only thing that contributes to the units digit is the multiplication of our two units digits in the actual factors that we're multiplying together. So, we realize that, we say, okay, Q must be the units digit of Q squared. Okay, when can that happen? Well, let's take a look. Q can only be certain things. Now, none of these expressions have sort of a leading Q other than the single Q here. So we still could have 0. We'll rule that out in a second. But they're all single digits. So we can make a list. Q squared is 0. Well, that ends in 0. Q squared, 1 squared is 1. That ends in 1. 2 squared is 4, so that's out. 3 squared, 9. Nope. 16 doesn't end in a 4. 25. Okay, there's a possibility. 6 squared, 36. That ends in a 6. That's fine. 49, 64, and 81. None of these count. So that tells me Q is 0, 1, 5, or 6. Now, it can't be 0, because otherwise this expression at the bottom would be 0. So that's out. And it can't be 1, because if it were 1, we'd just have PPQ again. But we go from a 3-digit number to a 4-digit number, so it's definitely not 1. So Q is either 5 or 6. Okay, and is there any other information to help us narrow it down? In the multiplication shown, P, Q, and R are all different digits, but it doesn't necessarily mean that they are different from 5. So, I don't think... Q probably is 6, but... maybe it is 5. I don't know. But Q is either 5 or 6. Either way, I know that we're going to carry some things. Okay. So now what have we got? Well, we have PP, Q times Q, and we get R, Q, 5Q. Okay. Well, I suppose we just said, well, what if Q is 5? Well, if we can get a P and a Q and an R that work with this, that's fine, then we're done. So we'll have P 5 times 5 is R 5, 5, 5. Okay. So what would we need to have happen? Well, we'd get 5 times 5 is 25, and then we'd have 5p, well, 10 times 5p, so I guess 50p. And then we'd have 100 times p times 5. So that'd be plus 500p is equal to r 5, 5, 5. So that tells me 25 plus 550p is equal to r 5, 5, 5. Subtracting 25 from both sides, we get 550p is r 530. But there's no way 550 times p is going to end in a 30. Divide both sides by 10. You'll get 55p is r53. But this is a multiple of 5 on this on the left-hand side. But if something ends in a 3, that's not a multiple of 5. So q can't be 5. That tells me q must be 6. So it's a fun little logic puzzle. So q is 6, great. Now we're looking at p 6 times 6 is r 6, 5, 6. Okay, well again, how do we multiply these out? Remember, when we say p6, that's 100 times p plus 10 times p plus 6. Okay, so we get 36, and then we have 60p, and then 600 times p. We add all those up, we get 36 plus 660p, and that should be R656. Okay, so now subtracting 36 from both sides, we get 660 times p, and it looks like R620. Divide by 10 on both sides, we get 66p is R62. And now we ask ourselves, okay, what are some multiples of 66? You know, what values could p be? I'm going to start p at 1, because there's no way p is going to be 0 here. 2, 3, 4, 5. We can skip over 6, because remember they're different. So 66, well, that doesn't end in a 6-2. Okay, we're looking for 3-digit numbers that need to end in 6-2. How about multiplying it by 2? Okay, well, that would be 132. Well, we're not quite there. It's a 6-2. 66 times 3. That'd be 198. Again, doesn't quite look... I mean, we need to definitely have 6 and 2 being what we're ending with. How about 4? Well, we get 2, 6, 4. No, that's not good. 5, 3, 3, 0. We skip over 6. And we get 7 is 4, 6, 2. That's going to be right on the money. And we'll just fill out the rest of the chart. 5, 9, 4. But this is the one we're looking at. So R is 4 and P is 7. So R plus Q, or P plus Q plus R is 7 plus 6 plus 4, or 17. Is 17 one of our answers? Yep. There it is at the end. So we have an answer of E. I like it when they occasionally include these sort of logic puzzle, figure out the digits questions. It's not a whole lot of complicated math. Like, you don't need to know any weird geometry things or anything like that, or any particular formulas. It's just good old-fashioned, you know, numbers, times tables. Could it be this? Could it be that? I don't know. Let's try some cases. I like a question like that. I think it's a good question. We've got one more to go on this contest. That'll be question number 25. I will see you guys in the next video for that. Feel free to like or subscribe or anything like that just to show your support. And I will see you for wrapping up the Gauss paper in the next video.